Welcome to the continuation of EDU 8307. I want to bring you back briefly to our big picture. So here it is. Obviously, we're still in quantitative world. The material before the first exam was found over here under descriptive statistics. So we've made our way all the way through to our last measure, which was of a relationship using Pearson-R and regression and covariance. Now we're heading over into inferential statistics. Before we get into the different tests that we're going to investigate this semester, I want to talk to you a little bit about inferential statistics, sort of in general. When we talk about inferential statistics, we're talking about those chance factors inherent in forming samples that always affect sample results. And sample results must be interpreted with this in mind. So basically what that means is no matter what sample you pull, no matter how sophisticated the sampling technique, there are always going to be, let's say, flukes or peculiarities about that particular sample that may not hold true if you were to pull another sample. So the differences between those samples or among those samples that are just kind of inherent is known as sampling variation. We treat sampling variation with this idea of statistical inference. We do so through probability. So chance is usually examined in terms of probability. When we study chance, it's known as probability theory, and we use probability in our everyday thinking, but it's more subjective. For example, think about what's the probability it'll rain, or what's the likelihood? Oh, it feels cold this morning, so I'm going to take my jacket because it'll likely be cold the rest of the day, and so on. So we have this idea of probability, but it just kind of comes into play on a one-on-one basis. Statistical inference, on the other hand, gives us a way to treat the study of probability with more objectivity, at least more objectivity on the surface. When we start to dig a little bit deeper, we're going to see that just like with descriptive statistics, researcher judgment is going to be critical here. You, as the researcher, will have the opportunity to make decisions all along the way in your study that can impact the outcome. And so a course like this is really a first look into all beyond what we're doing. You're really getting an opportunity to get a peek into what decisions need to be made, should have been made by you or by someone you're reading. If you're reading an article, I want you to be able to read those methods and those data analyses sections and really be critical. Did they do what they were supposed to do? And can I rely on these results that these authors are presenting? So anyway, I got off target a little bit there. So let's look at some probability examples. So what's the probability of flipping one fair coin and landing on heads? 50%, right? What about tails? Also 50%. What about neither? 0%, right? When we flip it, it's going to land on something. Think about drawing a diamond from a deck of cards. What's the probability of drawing a diamond from a deck of cards? Well, there are 52 cards in a deck, 4 suits, 13 in each suit, so 13 out of 52, right? And if we were to kind of divide that fraction that we just made, 13 out of 52, we can chart those results. We can chart them here in a relative frequency distribution. So let's look at this example. In a relative frequency distribution, we put what would be expected. So if we were to infinitely sample from a fair deck of cards, we would expect 25, 0.25, 0.25, 0.25, 0.25. So the probability of pulling one of each suit is 0.25. Or when we start to think about this, we can think about it in terms of 25%. What are the odds, or what are the chances, or what's the probability of pulling a diamond? Well, it's 25%. So distributions based on what we would expect, we call those a theoretical distribution. When we have a distribution of some actual data, we call those empirical distributions. Now, we can still calculate the relative frequency, and we can still talk about probability, but now we're basing it on actual data, not over here what we would expect to happen. So this is a distribution of a rather large class of students, 200 students. So the distribution, or the frequency of A's, B's, C's, D's, and F's, you can see over here how many first out of 200. And then when we go ahead and divide, for example, 30 divided by 200, we're getting the relative frequency. So 0.15, or 15%. So 15% of these grades were in the A category. Okay? So if we think about probability, it is a proportion. And we saw that when we had 13 over 52. And we divided it and came out with that decimal. So it's a proportion. It's going to be between 0 and 1. Because if you think about it, you can have no probability all the way up to 100% probability. But we can't go less than 100, and we can't have less than 0, and we can't have more than 100% probability, right? When we look at it in writing, in the literature, and then when we're writing our own work, we're going to symbolize it by this lowercase italicized p. And it's usually expressed in terms as a decimal, but you can kind of mentally know that you could think about that as a percent. All right. In fact, any relative frequency distribution can be interpreted as a probability distribution. So the ability to make statistical inferences is based on knowledge of the probability distribution appropriate to a situation. And that point may not make a lot of sense to you right now, but as we continue, what you're going to see is that normal curve, and the area under the normal curve is going to come back into play, except instead of talking about what percent or what proportion of students did I score better than, or so, something like that when we were doing, or what are the percent of scores below an 80. Instead of thinking about it like that, we're going to start to think about our value. Instead of being a score, it's going to be maybe an obtained mean that we got from our sample. We're going to figure out what's the probability that we would have obtained that mean we got. Okay? So just kind of hang with me on this second point, and it'll become clear as we go along. All right, so as an illustration, I want you to think about a situation where we have 4 coins. We're going to flip, if I can get myself right here, we're going to flip, we're going to flip 4 coins and see how many heads, or what are all the possibilities, I should say. So 4 coins. All right, so I'm going to draw a line down here, and we're going to think about the order of these. I may have written these too close together, so let's see. 0, 1, 2, 3, 4. All right, so say you take your 4 coins, and we're talking about heads. I'm just going to put an H. All right, if I flip my 4 coins and I don't land on any heads, so this is number of heads. If I land on no heads, what is my result going to look like? Okay, and what I mean by that is if I flipped my 4 coins and I didn't get any heads, I'm going to end up with this, tails, 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 right? Okay, kind of see how this works. What would the possibilities be for me to get 1 head? Okay, so I could get a head with my first toss and then the rest tails, right? Head, tail, tail, tail. Another way I could end up with 1 head is if I did tail, head, tail, tail. I could do the next one, which you probably guessed, tail, tail, head, tail. And then finally I could have tail, 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 head. All right, and so then thinking about, are there any other combinations I could get when I flip my 4 coins and only obtain 1 head? Okay, now what about, let's wait on 2. What about 4 heads? What would that combination look like? That would be head, 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 right? Okay, there's no other way I could flip and end up with 4 heads. What about 3 heads? What would that look like? Okay, so I could do head first, get 3 heads, and then a tail. I could get a head, head, and a tail right there, and then a head, and then a head, a tail, a head, and then a tail, head, head. Now when we're doing this in class, the students are calling all these out to me. I'm not giving them to them, but since I can't hear you guys, I'm just going to help you with it, I guess. All right, well, now let's do the middle one. What are the different combination of ways I could get 2 heads? Well, I could get the 2 heads first and then 2 tails. Or I could get the reverse of that. I could get 2 tails and then 2 heads. I could get a head with a couple tails in the middle and then another head. I could get tail, head, tail, head. Oh, let's see. Well, got that. Let's see. Oh, I could do head, tail, head, tail. 1, 2, 3, 4, 5 possibilities. So there's got to be 1 more. Head, head, tail, tail. Oh, I know what it is. It's tail. The head's in the middle. I don't have that, do I? I don't even know if you can tell with all that messy writing. Okay, so let's look at our possibilities. If you can make your way through all my writing, let's count how many possibilities there are. So I could have gotten this result. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 different results I could end up with if I were to flip 4 coins. Okay? Out of the 16, I only had 1 out of 16 possible here. All right, 4 out of 16 here. Remember we said probability is a proportion, right? We had 6 out of 16 possibilities here, 4 out of 16 here, and again 1 out of 16 here. All right, so if we were, or when we do, we can take this information here and plot it or put it in a relative frequency distribution, which we know is also a probability distribution. So we can say the probability of flipping 4 coins and having all 4 land on tails is 1/16. the probability of flipping 4 coins and landing on 2 heads is 6/16, and so on. Okay, so you see how that works? And if you kind of look at my rather poor drawing here, if we were to think about this, we could think of it in terms of that nice normal distribution. We have the bulk of our possibilities here in the middle. Anything that's out toward the tail is a lot less likely, right? Out here, we only had 1 out of 16 as a possible result to get head, 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 head. So the probability of landing on all heads is small. Same thing for all tails. A little more likely for 1, a little more likely for 3, and then 50-50, all right? 2 out of 2 heads out of the 4 coins was the most likely. So just like in a distribution, just like when we looked at those scores under a normal curve, results that fall here in the middle are more likely. Any result out toward the tail is less likely. Okay, so let's see what that looks like in a nice neat table instead of my messy writing. There we go. All right, and so here, to get no heads, that frequency, we knew that. We had 1 opportunity out of 16 to get that result. The relative frequency is this 0.0625 or 6.25%. 1 head, we have about a 25% chance. 2 heads, 37.5% chance. 3 heads, 25% chance. And then 4 heads, the 6.25% chance, right? So the probability in the tails of our distribution is a lot smaller than the probability in the middle of our distribution. Or in other words, it's a lot more likely to get 2 heads than it is to get 4 heads or no heads. Okay? All right. If we think about it in terms of the normal curve, like I was saying, the normal curve can be viewed as a theoretical probability distribution. And this is what I was saying earlier. When we previously found the percentage of scores that were above or below a certain raw or z-score, those percentages could be interpreted as probability. Okay, so remember back when we did the probability of scoring at or below a z-score of -1. And so we went and we lost my pen, hold on. We went and we looked in the back of our book for those probabilities. And so if I were to refresh your memory a little bit, remember z-scores have a mean of 0 and a standard deviation of 1. And we'd have our nice normal distribution. And so the probability here, right there, we would want to come up and then figure out this percentage right here. So if you were to go and look in the back of the book, you would find, look in the table, you would find that P, because now we're going to start talking about it in terms of probability, is 0.1587. All right, so if you don't remember that, get your book out, take a look, and find the z-score of 1, because remember it's just a mirror image. Find a z-score of 1 and see what that value is, and you should find it to be 0.1587. So if it's probability, and I'm thinking in my head, or I could even write it, 15.87%. So I had a 15.87% chance of obtaining a z-score of -1. So this probability right here is going to be greater. Anything, the further out in these tails you go, probability is going to shrink. Not down to 0, because remember that property of a normal distribution, it's asymptotic. It never reaches this x-axis, never quite touches, goes on for infinity, but our probability decreases to practically zero the further out we go. Okay, so that's a brief intro to inferential statistics and probability. We're going to continue and look at null hypothesis significance testing.